Hello and welcome to the 22nd Algorithm Selection and Development lecture in this course, Master in Artificial Intelligence. So in this lecture, we will talk about how to deploy and monitor the algorithms to become a successful artificial engineer, right? So we are in the last step of this whole big process of understanding the big process of researching, selecting, and developing appropriate algorithms. And in that, we will now talk about deployment and monitoring. And in deployment and monitoring, there are three steps as you see here. Deploy the trained model in production environment and integrate it into application workflow. Implement monitoring and logging mechanism to track model performance, drift, and errors over a period of time. And continuously evaluate and update the model as the new information and data become available or requirements keep changing, right? So how do you think you can deploy the trained model in a production environment and integrate into application workflow? Any thoughts? See, this requires several steps to ensure that the model performs reliably and efficiently. So let's take a look at how to do that in the next couple of slides. So what you need to do is start with preparing a trained model, right? Serialize or save the trained model along with any pre-processing steps or dependencies required for inference. Choose a serialization format compatible with your deployment environment, such as Pickle, ONNX, or TensorFlow's saved model format. Then you choose a deployment environment. You select a deployment environment suitable for your application's requirement, scalability, and infrastructure that you have. And here options include platform, AWS, Google Cloud, Azure, on-premise servers, edge devices, or containerized environments like Docker and Kubernetes. Then you set up the deployment architecture. You provide the necessary infrastructure and resources. You provision for them for deploying and serving the model, and ensure sufficient computational resources and storage and network capabilities are available to handle inference requests and serve predictions efficiently. Then you deploy the model, the serialized model to the chosen deployment environment, and depending on the deployment environment, this may involve uploading the model file to cloud storage, deploying the REST API endpoint, or deploying it as a server-side function. Then you create an inference service, set up an inference service or endpoint to handle inference requests and serve predictions from the deployed model, and implement logic to load the serialized model into memory, pre-process input data, perform inferences, and post-process output predictions. And then you ensure scalability and availability. You design the deployment architecture to scale horizontally or vertically as needed, or uh, pre-processed input data, perform inferences, and post-process output prediction. Right? So that's what you do in this case. Then another few things you need to do is to integrate with application and workflow. Integrate the deployment model into application workflow by connecting it into relevant components or services. Update applications code to make inference requests to a deployed model endpoint and process the prediction returned by the inference service. Also, you need to implement monitoring and logging. Set up the monitoring and logging to track the performance, usage, and health of the deployed model in real time. Monitors metrics such as latency, throughput, error rates, and resource utilization to detect issues and optimize performance. Implement security measures to protect the deployed model and inference service from unauthorized access, data breaches, or malicious attacks. Use authorization authentication and encryption, and other security best practices to serve communication channels and data storage. Train the deployed model through thoroughly to ensure that it produces accurate and reliable predictions in the production environment. Validate the integration with the application workflow and conduct end-to-end testing to verify that the deployed model meets the desired functionality and performance requirement. And then continuously monitor the deployed model performance, usage patterns, and feedback from users to identify opportunity for optimization or improvement. And finally, maintain and update the deployed model as needed to incorporate new data, improve performances, or address changing business requirements. Now, by following these steps, you can deploy a trained machine learning model into a production environment and seamlessly integrate into an application workflow, enabling your application to leverage the power of machine learning for real world use cases. And we will talk about this in a separate section as we go forward. The second thing you would need to do is to implement monitoring and logging, and how to implement monitoring and logging mechanism. So there again, what you need to do is a series of steps. So we will take a look at that, and this step is important to maintain the reliability and effectiveness of the deployed machine learning model. Now, what are the steps you need to do it effectively? Let's take a look at them. So first, you need to define the metrics naturally, right? Identify the key metrics that are relevant for monitoring the performance of your model. These metrics could include accuracy, precision, recall, F1 score, mean squared error, root mean squared error, inference latency, throughput, and others as we have gone through. Then you set up a logging infrastructure, choose a logging framework or service to collect and store log data generated by the deployed model. Now, the popular logging solutions include ELK Stack, Splunk, Prometheus, Grafana, and custom logging libraries. Then you instrument your model code to log relevant information during model training, inference, and evaluation, and then log key metrics, input data, predictions, errors, any other relevant metadata that can help diagnose issues or monitor performance. Then you log model predictions, uh, model predictions made by the deployed model using the associated feature inputs and ground truth labels, and include timestamps and unique identifier for each prediction. Then you monitor performance matrices continuously by deployed model, especially for the metrics logged by the deployed model to detect changes or anomalies. And you set up alerting mechanisms to notify stakeholders when performance metrics deviate from expected values or thresholds. And also you detect concept shifts, drifts. You implement mechanisms for detecting such drifts, a change in underlying data distribution that may impact the model's performance. And you monitor the distribution of input data and compare it to the historical data to detect these shifts or drifts, and use statistical test divergence measures or machine learning models to detect and quantify the concept drift, right? Uh, few final 5 steps. You track model versioning, maintain model versioning of the deployed model and associated artifacts like pre-processing steps, feature engineering pipeline to track changes over time. You log model version information along with prediction data to facilitate traceability and reproducibility. Then you capture and log errors, exceptions, and failures encountered during model training, deployment, or inference in whatever the stage it happens. Include stack traces, error messages, and contextual information to aid in debugging and troubleshooting. Then you implement data drift monitoring to ensure that the deployed model remains relevant and effective. It remains relevant to the data that you use to create it. You track statistical properties of the input feature and compare them to historical baseline or in reference distribution. Then you visualize and analyze logs. So use visualization tools and dashboards to analyze or visualize log data, performance metrics, and drift detection results. Create interactive visualization, charts and graphs to gain insights into model behavior and identify trends or patterns. And finally, regularly review and audit logs to identify potential issues, trends, or patterns that may require attention. And you conduct periodic audits also of model performance, drift detection results, and error logs to ensure that the deployed model meets the desired performance and quality standards. So by implementing robust monitoring and logging mechanisms that we took you through, you can track model performance, drift and errors over time, enabling you to detect issues early, diagnose problems effectively, and maintain the reliability and effectiveness of your deployed machine learning model in the production phase. Finally, you need to continuously evaluate. So what this again requires is important for maintaining the effectiveness of your machine learning model. And how to do that? Let's take a look at the steps you need to do. So you need to define the monitoring schedule, establish a regular schedule of monitoring the performance of the deployed model and assessing its alignment with the problem requirement as well as data. Determine the frequency of evaluation based on the rate of data arrival, nature of the problem, and the criticality of the model's prediction. Then you implement a robust data collection pipeline to ingest new data and prepare it for the model evaluation. Ensure that the pipeline captures relevant features, pre-processes the data appropriately, and maintains the data quality and integrity. Then you continuously monitor data drifts, changes in distribution of input data over a period of time, enhance data drift detection mechanisms to detect and quantify shifts in the data distribution, and trigger alerts or actions when significant drift is detected. Then you define evaluation metrics and criteria to assess the performance of the deployed model on the new data. You need to include metrics related to accuracy, precision, recall, F1, AUC, and any other relevant model indicator for the problem domain. And then establish a schedule for periodically retraining the deployed model using the new data. Determine the retraining interval based on the rate of data arrival, the model's performance degradation over a period of time, and the resources available for retraining. And then automate the model retraining process to minimize manual intervention and ensure consistency and reliability. Set up the pipelines for data processing, model training, validation, and deployment to streamline the retraining workflow and automate this retraining pipeline. Then finally, last few steps, you need to implement techniques for incremental learning to update the model gradually as the new data becomes available. Explore online learning algorithms, transfer learnings, fine tuning, and essential methods to adapt the model to changing data distributions and requirements. Maintain version control of for knowing what is the status of and version control of model artifacts, model things, code, and data to track changes over time and facilitate rollback if necessary. Keep a record of model versions, training data, hyperparameters, and evaluation results to ensure reproducibility and traceability. Validate the updated model thoroughly using validation data sets, holdout sets, or A/B testing to ensure that it meets the desired performance criteria. Conduct rigorous training and validation before deploying the updated model to production to minimize the risk of introducing regressions or performance degradations. Continuously monitor the performance of the updated model in the production environment to verify its effectiveness and reliability. Monitor the key performance matrices, drift detection results, etc. And finally, establish a feedback loop to collect feedback from end users, stakeholders, domain experts regarding the performance and usability of the updated model, and use feedback to iterate on model improvements. So by implementing these steps, you can ensure that your machine learning model remains up to date, effective, and aligned to the evolving requirements of the problem domain, enabling you to drive maximum value from your model over a period of time. So, by following these steps in the whole process of this, how to research, select, and develop algorithm, the process of understanding problem, data pre-processing, researching, interpretive, model selection and evaluation, developing, iterative development and optimization, doing interpretation and explainability, and finally deploying. You can develop a machine learning algorithm tailored to the specific problem at hand and characteristic of the available data. So what do we do next? So let us now look at an example of this whole process of researching, selecting, and developing appropriate machine learning model, and also deep learning algorithms based on the problem at hand and on available data. So thank you so much for watching this 22nd algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your question, and also download the PDF file to take a look at anything that is of specific interest to you.